Hey everybody, this is Paul. Welcome to the third part in determining whether or not numbers are prime numbers. So what I wanted to do in this tutorial is I wanted to create a function in C++ that can actually just print a whole list of prime numbers from some starting point to a stopping point. So what we're going to do to make that happen is we're just going to create another function, and it's not going to return anything, so it will be a void return type. And we're going to name this function listPrimes. And like I said, we're going to have a starting number and a stopping number, so both of those will be integers. So we'll do int start and then comma int stop. So these are the two things that we're going to basically pass in our function, pass into our function. We're going to pass in a starting position and a stopping position. And so what we're going to do is we're going to start at the start number, and we're going to see if that's prime, and if it is, we'll print it to the screen, and then we'll add 1 to that number, and we'll test to see if that number is prime, and if it is, we'll print that to the screen, and we'll keep on going until we get to the stop number. And we'll just check all of those numbers to see if they're prime, and if they are, we'll just print them to the screen. So that's what our listPrimes function is going to do. So let's go ahead and just copy this right here. And then below our main program, we'll go ahead and define it. So there's my isPrime function that I wrote in the last video. So here we're going to do the listPrimes function. So there we go, and let's see. Okay, so inside of these curly braces we're going to define the listPrimes function. So the first thing we're going to do is we're just going to do a couple error checking statements. So what we're going to do first is we're just going to say if our start value is greater than our stop value, then we're just going to tell the user that there's an error, because we don't really want to try to figure out what they mean by that, because basically we're going to start at some value and we're going to stop at a value that's greater than that. So if our start value is greater than our stop value, our program's not going to really know when to stop. So if the user enters the start and stop values backwards, we're basically just going to let them know that they entered it in the wrong order, and we're not going to process that request. So we're just going to say error, and then we'll just say start. Maybe I'll make it lowercase since it's a lowercase variable here. So start value is greater than stop value. So if that's the case, we're just going to send out that error message, and then we're just going to exit the program, and we're going to give it a status value of 0. So status value of 0 just basically means that everything was fine, everything executed successfully, it did what we wanted it to do, but we want it to exit. So if start is greater than stop, we're just going to say, okay, we don't want to deal with that, and we're going to exit the program. So the other case we're going to check for is, I'm not going to really write any code for the case that the start value is less than 2. So I'm going to say if start is less than 2, we'll just do another error message here. And we're just going to say error start value is less than 2. And then we'll put a new line there. And so basically we're just doing a little bit of error checking, so that way if somebody types in the wrong values and they don't realize it, the program's not going to try to process those requests, because we're not really going to put any logic in there to handle these two cases. And I guess we should probably do exit 0 here as well to let it know that we want to exit the program. So basically, once it gets past these 2 points right here, if everything's okay, if it doesn't fall into either of these categories, then we can go ahead and basically do some logic on all the values starting at the start value and ending at the stop value. And we're going to check to see if any of those values are prime, and if they are, we're going to print those values to the screen. So I'll go ahead and stop the video here, and we'll go ahead and write that logic in part 4 of this series. So we'll see you guys in the next video. Thanks for watching, and if you haven't already, don't forget to subscribe.